Hey there, boys and girls, it's Mr. Jones, and I'm back with another math learning video. So today we're going to talk about powers and prime factorization. So a power is a number with an exponent, which is a small number written in superscript, which means it's a tiny letter, or a tiny number, written a little bit above the other number, which is an expression of a product of equal factors. So in this case, we have our factors are 5 times 5 times 5 times 5. And so our exponent is written as a base number, or our power, is written as a base number with a small exponent. And again, the whole thing is called a power. So we've got base, exponent, power. Just a reminder, the term product can mean both the result of multiplying, like the answer for multiplication, but it can also refer to the factors being multiplied. So 2 to the 4th power times 3 to the 3rd power is a product, just like 144 can also be called a product when we're talking about multiplication expressions. Example 1, we can use exponents to represent the products in our prime factorizations. So in this case, I've done some of the heavy lifting here, and we've done our factorization tree, and we figured out that our primes here are 4 5s. So we know that 625 is the same thing as 5 times 5 times 5 times 5, or 5 to the 4th power. Example 2, write each product as a numeral or a number in standard form. So those mean the same thing. So we have 2 to the 6th power times 5 to the 2nd power. Here I've written them out as repeated multiplication. You don't necessarily have to do that, especially if you can do some of the math in your head, but it's a good way of showing me that you understand what those exponents represent. And so now, and if we have expressions written in brackets and the brackets are side by side, you multiply. So when we go back to BEDMAS, that's what's implied there. So 64 times 25 is what this expresses, and our product is 1600. Example 3, write the number below as a product of prime factors using exponents. So here, again, I've done something slightly different. It's sort of like our factor tree, but here I've just broken down the larger factor in each pair into a smaller expression, and I just did that repeatedly. And what I'm left with is 5 primes, 3 and 4 2s. Because 2 times 2 times 2 times 2 is 2 to the 4th power, the product here is 3 times 2 to the 4th power. All right, so this was a short video today, but I hope it helped you understand exponents a little bit better and some of the terminology that we use when talking about exponents. I'll do another video over the next few days that will help us with calculating least common multiples. So stay tuned for that. All right, thanks for watching.